Alrighty folks, how are we doing? Today, in this video lesson, we're going to take a look at the charging of objects. Specifically looking at the just different methods that we're going to go about to get an object to have a different charge, right? Whether it's we give an object a positive charge, whether we give it a negative charge. Because at the end of the day, something that is neutral, being in its normal natural state, is free to adjust pretty regularly pending circumstances. So what we're looking at here, we've got four main methods that we can charge particles with. Your first one, right, we can charge something by friction. We're going to see this, we're going to do this one quite a bit in lab. Polarization is the next one. Conduction, which is also charging by contact. Again, we're going to use those two terms interchangeably here. Conduction or contact, and then induction is the last type of charging. All right, so charging by friction. When we charge an object by friction, what that means is that these two objects are rubbing up against each other. We've talked about friction this year. We've studied friction this year. You guys are 17, 18 years old. You know what friction is. It's when two objects rub against each other. But when objects rub against each other, what's happening from an electrostatic standpoint, from those charges that all objects possess, is they're being physically ripped to going from one material to the next. And that's how we get this charge, because these objects, as they rub, they're going to tear those electrons away from one another, right? One object is going to be more willing to take those electrons, and the other one not as willing to take on those excess negative charges. Now, some examples here are when you rub your feet across your carpet. I mean, picture you wearing those footy pajamas, or you're dragging your socks on your feet, right? And you're just kind of dragging your feet, and then you touch that metal doorknob and you get shocked. Well, what's happening there is your feet, as they rub across that carpet, are drawing the electrons away from it, which is giving you a net negative charge. So then when you go to touch a conductive material, you're going to let that shock go, right? Those electrons are going to flow out of you in the form of a shock, right, a spark, and go to that doorknob. The atmosphere dragging across the ground is the next one on there. What's going to happen there is the atmosphere sits directly on the ground, right? We're breathing in air all the time. That air is coming from the atmosphere. And the earth rotates and the atmosphere moves, so we get this constant dragging of the atmosphere along the earth's surface. And that's going to draw in some charges as well. Silicon glass, that's the next one. And in lab, we're going to see this quite a bit. We're going to take some silk, some fur, right, whatever it may be, and you're going to be able to charge objects with it by rubbing that fur across whatever that object may be. In this situation, it's glass, right? We're giving an object a charge. The last one is probably the second most entertaining of the bunch here. When you take a balloon and you rub it against your hair, what you're doing is that violent rubbing of that balloon against your hair is ripping the electrons away from it, right? So that balloon takes on a net negative charge, leaving your hair with a positive charge. So when you go to pull the balloon away, that's why it's drawn together. That static that we hear is the difference in those electric charges, right? It's the attraction of the positive and the negative charges, right? The positive on your hair and the negative on the balloon. Now, this bullet point down here talking about electron affinity. That is how we define which object takes the electrons and which object loses the electrons as a result of friction. If it has a high electron affinity, think of the word affinity meaning it likes something, it wants something. Well, if it has an affinity for electrons, that means it wants to take those electrons any way that it can. So when two objects rub against each other and we charge them via friction, the object with the higher electron affinity is going to take those electrons away from the object with the lower electron affinity. If it has the lower affinity, it's more willing to give up electrons to gain a positive charge. So as a result, the object with the greater electron affinity becomes negative, the object with the lower electron affinity becomes negative. And whether it's a conductor or an insulator, right, because that, depending on your objects there, if you charge by friction and you have an insulator, because insulators don't allow those charges to move once they get to it, it's going to be a point where all of those charges sit. So when it charges by friction, once those electrons get to that insulator, they stay at that location. Unlike a conductor, where those charges will get to it and then evenly disperse along that conductive surface, because the conductors let those electrons flow and move and space themselves out. And they're going to want to space themselves out because they're all going to have like charges. And if they're going to have those like charges, that means they're going to repel from one another. Polarization is our next one, right? We're going to have a nice little simulation here for you guys. What we get for polarization is we take a neutral object, in this case the purple sphere, and a charged object, in this case the negatively charged red rod, off to the right side here. And what's going to happen is as you bring that charged object close, what we see happen is based on the electrical forces and that opposites attract and likes repel, the negativity of that rod is going to push the electrons in the neutral sphere away, because those negatives are free to move. The electrons can move where they please, so it's going to push them away. And that forms that dipole. Remember, a dipole is something that has two definitive sides. So here we have a side that is definitively positive and a side that has become definitively negative. Even though that sphere is still neutrally charged, it has an apparent positive side and an apparent negative side. Now this example here is shown with a negatively charged rod. The opposite would happen with a positively charged rod, where those negatives in the neutral would then go towards the positively charged rod. Same thing, you're still making a dipole. It's just a matter of which direction those electrons want to travel in that neutral object. Our next type is charging by conduction, so charging by contact. Again, this can only happen, it only counts as conduction when there's contact. Polarization doesn't need contact. Conduction does. Because what's going to happen with conduction is we're going to make contact here, and then we're going to see a flow of electrons as they're in contact. So same setup here, right? We've got our neutral sphere, we've got our negatively charged rod. The first step is always going to be polarization, because when you bring it near that neutral object, no matter how fast you do this, it's going to polarize. So we get polarization to occur, where those negative electrons in the neutral sphere are going to be pressed away from that negatively charged rod. But now we're going to have contact. And with contact, the electrons are free to flow from the negative charged rod to the neutrally charged sphere. As a result of this, when we remove that negatively charged rod, we now have two negatively charged objects. That sphere has now taken on excess electrons, giving it a negative charge, and the rod still has a negative charge. So as a result of this, we get two negative objects. Now this bullet point that just popped up here, on the flip side of things, if we had the positive rod and a neutral sphere, what would happen there is we would see the electrons flow out of the neutral sphere to the rod, and then we're going to be left with two objects that have a net positive. Basically what's happening is they're sharing those electrons, right? They're taking those electrons and they're basically splitting the difference of them, and that's going to leave each of them with a slightly negative charge in this example, or a slightly positive charge if we have a positive and a neutral. Right, so that's what we have here by conduction, the flow of electrons that's going to cause both objects to have the same charge once they're pulled away from each other. Last type here is charging by induction. Last type is charging here by induction. Difference here between induction, conduction, polarization is this is just the next step. Right? That's all that's happening here. First step, as always, we polarize. Right? So no matter what we polarize. So again, we've got negative charge object. So we're going to repel those electrons. They're going to go away from that negatively charged rod. Next, we are going to do what is known as grounding. Grounding is an extremely important process, and we'll get into that for electric circuits. But basically what happens is you're giving these electrons a chance to leave an object. So if you ground something, that means that you are allowing those negative charges, right, those electrons, to flow out of the object and somewhere that is completely independent and completely removed from your neighborhood. Basically, the objects that we're talking about. And that's what we see here as that black line coming out of the sphere. That's their symbol for grounding. And as you saw in that simulation, and I'll run it back for you here, right? So we polarize it, and when we get grounding, watch those electrons flow out. And those electrons are going to continuously flow out until either there's nothing left or you remove the polarization, right? They're going to keep moving and moving and moving and moving and moving because they're able to repel. Think of it as you're giving those electrons in that neutral object a chance to get further away. Because ultimately when you polarize, you're giving those electrons, right? You're pushing them away and they're getting pushed as far as they will physically go based on the electrical forces that are at play. But as soon as you ground it, you're giving them a chance to get further away from that charged rod, and they take the opportunity. They are electrically repelled based on having like charges. So because they have those like charges, they move away. You give them a chance to get further through grounding, and they do, right? They're going to get further and further and further away. So then when we remove that ground and we remove the charged object, now we have two oppositely charged objects. So that negative rod stayed negative because there was no contact, right? So there was no transfer of electrons there. But because the neutral sphere had those electrons leave, as they left, it makes that sphere have a net positive charge. So that's what we look at here for charging objects, right? Those are our four main methods. We're going to look at these in lab, right, in the electrostatics lab. And you're going to get practice being able to do each of these types of charging methods. That's all for today. Thank you for watching the video lesson. Again, feel free to go back, rewind, go through what you need to in order to get a better understanding of charging.